Hello, welcome back to my bench. Today, I just wanted to show you a little thing that I made that has proven to be very helpful, and it was quite easy. I cannot say I designed it. Designing means I came up with something new. This is, by no means new. It's just putting something into a package that's easy to use. What I've got here is a little op-amp tester. I got sick and tired of trying to figure out if op-amps are working the way that they're supposed to work, or if there's something wrong with them, or if they're shorted or whatever, and taking voltage readings doesn't always get it. This solves all those problems, and it's really cheap. Let's do a quick little demonstration of it. This is all self-contained, or it can have external inputs and outputs to it. Over here on this side, you'll see it has an on-off button, push button. It'll take 9 volts or 12 volts, or 9 volts in. Yeah, that's what it says right there. Around the front, it's got a scope output. See that? It says scope. And this is the internal and external oscillator. We'll see that in a minute. This is a 7-position switch that the first position is for the single op-amp over here. The next 2 positions are for number 1 and number 2 portions of the op-amp there. And the next 4 positions are for the 4 outputs of a quad op-amp over here. On this end, we've got external input so that you can feed it an input and be able to see how well the op-amp actually works if you want to do it that way. As it sits, it has about a 10 or 12 hertz NE555 oscillator inside of it that just puts out 12 hertz. The PCB was made by JLC PCB. They did a great job for me, even though I made some stupid errors because I'm horrible with KiCad, however you pronounce that. This just has 3 regular 14-pin and 2 8-pin IC sockets on the top of it. It would be nice if I could find 0 insertion 4 sockets for this. I'm thinking about doing it somehow with a 40-pin, but I haven't done it yet. I may not. So let's see how this thing works to start off with. We're going to start off with a single. This is a 741, I think, or is it a TLO 71? Well, before I do that, let me show you the schematic of it. Just because, why not? Here's the schematic. We've got, this is up here. This is your single input op amp, or single op amp up here. These are your 2 op amps here for a dual, and this is for the 4 op amps. Now, all of these are set at a times 10, I think. 10K, 1K, yeah, times 10. So they basically are just running whatever the input is over here on this side. They're running it at times 10 and lighting up LEDs out here on the outside. And all the LEDs are protected by a 1K resistor in case your output is shorted. It'll just light up the LED nice and bright. And also it's got an output over here to go to your the switch to switch the output so that you can look at it on a scope, which we'll look at here in a minute. This is your input over here, and it's just whatever input you want for frequency. I do not show on this diagram the internal oscillator that's on here. This is very much just a project proof of concept type of thing. It is not in any way, shape, or form meant to be a production model. One of the reasons why is because I put the wrong connector down here on this. I'll show you. I put right down here. I didn't look at the connectors I was using on the on KiCad, and I ended up with these ridiculously small little connectors, which worked out pretty well for this 28 gauge wire going down inside, but it's not pretty. And there's your plus or minus 15 volts for your op amps. The other thing it doesn't show in the schematic, the input is just 9 volts DC, and when we open it up, I'll show you the little board in there that's really kind of cool, that takes voltage in and gives you a negative voltage out. That's how I arrived at that. So let's just try one here and see how it works. I believe I put it. Oh, here's the picture of the board in case you wanted to look at it. It's pretty simple, pretty straightforward, and it's surface mount all up on this side, with the exception of the LEDs, which I didn't feel like going through the surface mount problem with them. But that's it. And like I said, JLC PCB did it for me. Anyway, here we go. Let's put there is a TLO 71 in the single area. And if I turn it on, see it flashing? That means it's good. Just as a single op amp. Let's do a dual. This is a TLO 82. No, and this is a 5532. This will take pretty much, if they're standard pinouts, meaning 7 and 4 for a single, 8 and 4 for the dual, and 4 and 11 for the quad. This will pretty much test every op amp that you come across, as long as they're single, as they're, standard. There are a few that it won't because they're not standard, but you don't run across those very often. So if I turn this one on, see them both flashing? That means that one's good. And on a quad, I believe, what is this? Is a TLO 74. Yeah. Turn it on. See them all 4 flashing. So there you go. That works. And that's all done internally. It's just sitting there with a box. Like I said, this is not a production model by any stretch of the imagination. So let's well, I'll tell you what, before we open it up, let's take an output here. This is where it kind of comes in handy. I'll take an output, which is coming from my little function generator. Right now it's set at 10 hertz. And let's go put a scope out. Put a scope on the output here, and bring up the scope, and I'll show you how this works. Let's put in the quad, turn it on, and we'll go to the external input, and as you can see, well, wait a minute. Why is scope not work? Did my scope die? Yes. The scope died. Hang on. I don't know why it does that. Every once in a while, the scope just flashes and goes off the screen. All right, so let's slow this down a little bit so we can see it. Okay. I've got a 1 volt input coming out of the function generator, and about 10 hertz. And you can see it there, about 10.03 hertz. And the lights, they are flashing away. Can you see that? Not really. There. Lights are flashing away. It's easier for me to see it here. But what you can do now is we can take the function generator. Where is it? The function generator. And we can speed this thing up. Let's take it up to 1,000. There's 1,000 hertz. And if we look at the scope again, there's my scope output. And I think you can see the light's just on solid, of course, all of them. But what we can do is we can go back to the function generator, and let's take this up to, I don't know, we'll just add another 0. There's 100K, or 10K, still on. There's 100K. They're not on anymore. Back that off. They're back on. We're down to 10K. And that 5532 won't do 100K. It's not supposed to. That's its limit. Okay, let me jump in here for just a second. I made a bit of a mistake. These TLO74s that I got a long time ago were, I think, $10 for 200 of them. And they definitely are not TLO74s. I don't know what they are, but they are definitely counterfeits. The TLO74 is capable of between 3 and 5.25 megahertz bandwidth. These are definitely not. So there you go. Not only did I prove that that you can measure it, I proved that these things are fake. Back to the regular programming. So you can actually test them up to the limits, well, the limits of your function generator anyway, and show you what, how, if it's working correctly. But if you take it down to 10, the nice thing about 10 is it does its flashing thing. All right. Now let's show you what happens here. If we go, boink, okay, yeah, it's a little slow to respond. Yeah, there we go. What happens here when you're on 10 is it flashes. Now let's take a look at one that is not good, and I'll show you what happens. This is from a thing that I just fixed. This is an NE5532, right there. We're going to stick it into the dual. Got to get better sockets, that's for sure, the next one I make. And we're going to turn it on. And if you look at it now, see, one side is flashing, the other side is solid, and it's getting warm. That means this guy is shorted. If we go to the output, that's 1, that's 2, and that's the second output. Look at, your scope just went straight off into Never Never Land. No oscillations. So if you leave it at 10 and you just check them, it's really easy because the lights will flash and they're good. If the one stays on, the way it works is if they flash, they're good. If it stays on solid, the output's shorted. If it doesn't come on at all, the IC is not working. or this thing can't read it. But I tell you, as standard ICs go, I've not found one it won't read yet. All right, so what we're going to do, we're going to open it up, and I'll show you the mess inside. Please do not laugh at me. Like I said, proof of concept, not ready for prime time. All right, here we go. The whole mess is running off of 3 AA batteries and a little holder that I stole out of a little one of those cheap flashlights. Over here on the side is the little NE555 timer with its associated. I've got the what do you call it? A linear regulator over here. I think it's a 9-volt linear regulator for the NE555. This is the switch here. It's one of those 12-position switches that's locked down to 7 positions. And this is your internal and external switch here for internal and external oscillator. This is your output. This is your on-off switch, and this is your input. And then the little board that's down here in the bottom, right there, that is the little... like I've got 9 volts going in. I got minus 15 coming out. So it works. It works just great. I love it. I mean, it's such a neat little animal. I mean, plus and minus 15 coming out of it. It's such a neat little animal. It gets rid of all of those problems that you have of trying to weird up batteries together and do things like this. You know, a couple of regulators and a voltage, and slice the sine wave in half, and it's just this thing was like a couple of bucks. We'll go look at that here in a minute. But anyway, there it is. It's pretty simple, but I'll tell you what, I use it constantly just for peace of mind and to know if my little if the IC is working. Really simple, easy, plug it in, turn it on. Yes, no, period. Wrong screwdriver. Okay. Anyhow, I love the thing. It works great, sits here next to the bench and just comes on when I need it. All right, so I guess what I'll have to do is, in post, I'll put up some... where I got a picture of the little thingy in here. Wait a minute. Hold on. Maybe I can do that now. Okay, I found it. Here it is. Let's bring that web up. And it was this guy right here. This little box. DC to DC mini boost step-up module. Single voltage to positive negative voltage. Total $4.12. I don't know how many I got. I think I got... yeah, well, they're 58 cents each, and I got 3 of them, or I forget how many I got. Anyway, and it cost a couple of bucks to get it shipped, I think. If we go over here, yeah, here we go. You can get them for the voltages of plus or minus 5, 9, 12, 15. I mean, really, they're really kind of cool, and you don't have to mess around with silly batteries and things all the time, but. Yeah, I got these from AliExpress, as you can see. So, anyhow, there it is. I just wanted to show you guys that. Yeah, just turn the lights off. My little box. It's pretty cool, and it works great, and I love it. And I think I'm going to work a little bit longer on KiCad and come up with something a little cleaner, with regular-sized connectors down here, because these are really hard to put in, and they're coming out the top of the box, whatever. But anyway, thank you, JLC PCB, doing a great job for me, and let me know if you're interested in this. Maybe I can get a few more of them made or whatever. I'm not going to put them together. You can put them together. They're pretty easy. It's a good bunch of resistors for SMDs, the surface mount stuff. Good practice. Nothing special about it, and they're all marked on the board, so you don't even have to go through that. Anyhow, there we go. Thanks for stopping by, and I hope you enjoyed this one. Give it a thumbs up if you did, and don't forget to subscribe, ring the bell if you want to hear stuff, and give us a like if you like the stuff. And don't forget that I've got a Patreon page too if you want to go over there and support me more directly so I can buy more parts for this thing. So till next time.